Good morning, friends. Today we are discussing formulation of LPP, and in the next problem we are taking the problem how to formulate a LPP and solving the formulated LPP using graphical method. In this problem we are learning how to formulate the LPP for the given statement. The statement of the problem goes like this. A firm manufactures three products A, B and C. The profits by selling each unit of these products are 3 rupees, 2 rupees and 4 rupees respectively. In the sense, by selling 1 unit of A, we are getting the profit of 3 rupees. Selling 1 unit of B, we are getting the profit of 2 rupees, and selling 1 unit of C, so 4 rupees profit is obtained. The firm has two machines, that is M1 and M2, and given below the processing times in minutes for each machine on each product. In the sense, 1 unit of product A is processed on machine 1 for 4 minutes. Similarly, 1 unit of B is processed on machine 1 for 3 minutes, and 1 unit of C is processed on machine 1 for 5 minutes. Similarly, for machine 2. Now the two machines M1 and M2 have 2000 and 2500 minutes respectively. That means the free available time of these two machines M1 and M2 are 2000 and 2500 minutes. The firm must manufacture 100 units of A's, 200 units of B's and 50 units of C's, but not more than 150 units of A's. That means the firm will produce minimum of 100 units of A's, but not more than 150 units of A, and it produces 200 units of B and 50 units of C. Set up an LPP to maximize the profit. So more products are manufactured means more profit. So let the number of units of products A, B and C are manufactured with X, Y and Z units respectively. In the sense, I am producing X units of product A and Y units of product B and Z units of product C. It is given that machine 1, that is tabulated here. So machine 1 is used for 4 minutes on one single piece of product A and 3 minutes for one single piece of product B and 5 minutes for one single piece of product C. Similarly, for machine 2, it is given that so it is used for 2 minutes for one single piece of product A and 2 minutes for one single piece of product B and 4 minutes for one single piece of product C. Now the constraint is that the machine 1 is available only for 2000 minutes. So here the constraint of machine 1 will be formulated like this. If for one single piece of product A, so if it requires 4 minutes, for X number of units it requires the time of 4 into X. Similarly, for one single piece of product B, it requires 3 minutes on machine 1. So it is 3 into Y plus 5 into Z. So the total sum of these three times should not exceed 2000 minutes as stated in the problem. So we are using here the constraint less than or equal to. Similarly, the availability of machine 2 is only 2500 minutes. So the constraint will be formulated like, so for one single piece of product A, the time taken on machine 2 is 2 minutes. If I produce X number of units of product A, the time consumed on machine 2 is 2x. Similarly, on machine B it is 2y, and on machine C it is 4z. The sum of these three times should not exceed 2500. So that's why we are using here less than or equal to constraint. Now, number of units of products produced cannot be negative. If I don't produce anything, my x, y and z values will take 0. If I produce some units of products, these x, y and z will take positive values. In no case they cannot be negative. So it is given that the firm should manufacture 100 units of A's, 200 units of B's and 50 units of C's, but not more than 150 units of A's, as it is stated in the problem, not more than 150 units of A's. So in the sense, X value is ranging from 100 to 150. Then it is said that minimum of 200 units of B's should be produced. So Y value is greater than or equal to 200, and it is said that 50 units of C's will be produced minimum. So Z value is greater than or equal to 50. Let Z denotes the profit. So my Z is equal to, it is now 1 unit of product A will get me a profit of 3 rupees. So from selling X units of product A, I am getting the profit of 3x. Similarly, by selling 1 unit of product B, we are getting the profit of 2 rupees. So by selling Y units, we are getting the profit 2y. Similarly, by selling 1 unit of product C, we are getting the profit of 4 rupees. So it is totally 4 into Z. So the profit is 3x plus 2y plus 4z. Hence the required LPP is formulated like this. Since we are concentrating on maximizing the profit, so my objective function is maximize Z is equal to the sum of the profits obtained from product A plus product B plus product C. So that is 3x plus 2y plus 4z. It is subjected to the constraints that so the constraint is formulated here for the machine M1. So that is written here, and the constraint for machine 2 is formulated here. So that will be written here, and the constraints on the number of units produced for product A. So the constraint is this: 100 is less than or equal to X, less than or equal to 150. For product B, the constraint is this, that is Y is greater than or equal to 200, and the constraint for product C is Z is greater than or equal to 50. So this is how the LPP is formulated. Here only the formulation of LPP is shown. So in the next problem we'll take how to formulate the LPP, and also we are finding the solution for the LPP formulated using graphical method. Thank you.